Hello, ladies and gentlemen. Mr. Hescox here. Coming back to my physical science class, we are going to start attacking 8.3 today. Be your warm-up question there. What are two ways of decreasing the solubility of a substance? To decrease the solubility, you can chill the substance, or you can remove pressure from the substance. So that would also decrease the solubility. What our acids and bases are talking about today. So everybody thinks about acids as, oh, it's melting, and then you're going to read tonight. I have a video built in here that you guys in class should be watching. What do you think of when you hear the word acid? You know, a lot of people think of like metals being melted and things like that, but what does it mean to be acidic? Acids and bases are literally opposites. Acids have very sour taste, like a lemon. Acids are going to affect color indicators. So your color indicators are usually litmus paper. Now, acids are red, bases are blue. Kind of like violets are red, that type of poem. Roses are red, violets are blue. In this case, acids are red, bases are blue. B for blue. And they changed this substance called phenolphthalein to be this bright, oh no, if they're a base, bases would change phenolphthalein, but acids leave phenolphthalein clear. Acids are going to react with metals to produce hydrogen gas, and atoms of acids contain loose hydrogen ions that we refer to as a proton, actually. So one of the most common acids out there is hydrochloric, which we write HCl. It's a hydrogen and a chlorine. And what happens? The chlorine takes the hydrogen's electron, and that poor hydrogen is just floating around without its electron. Well, most hydrogens are just a proton and an electron. So in the nucleus, you have one proton and one electron. One's positive, and that electron is traveling around the outside. The chlorine takes the electron. And that poor proton is just floating around, and that makes something an acid. So some common acids that you would find, they're always going to be written with a hydrogen in front, almost every single time. That hydrogen in front of the compound tells you that's an acid. Hydrochloric, sulfuric acid, this is battery acid. If you've ever worked on cars, there's an acid inside the car battery. That's battery acid. Nitric acid is used in industry all the time. An electrolyte is a substance that when it's in water conducts electricity. So acids have these charged particles already, therefore they cause water to be very good. They're a good electrolyte. Some very common weak acids. This is vinegar. If you watched my video the other day on vinegar and baking soda, the vinegar reacts with the baking soda and gives off carbon dioxide. Carbonic acid is actually the type of acid that's in your soda pop. As that carbonation is actually absorbed into the water, it causes the water to become slightly acidic. And then boric acid is another one that's used in some types of industry. So you guys in class should be watching this video too. But in the meantime, I'm going to go ahead and work on the bases, or the properties of bases. Properties of bases. Bases taste bitter. They taste kind of bad. Like if you've ever had soap in your mouth, like when you're a kid and your mom puts soap in your mouth, very, very bitter. Bases are slippery. That's why soap is slippery. Bases turn litmus paper blue. If there's nothing else you take from this section, bases are blue in litmus. Acids are red in litmus. Bases emulsify oils. Emulsify oils means this. So here's your drop of oil, and basically it'll capture around it with these base particles, and that causes it to be able to be dissolved in water. And bases are hydroxide ions. So you have an OH negative. Basically, it is a proton acceptor because it really wants an H positive. Well, when you have H plus OH, the final product, if you allow an acid and a base to come together, it's HOH or H2O. Good old water. Some very common bases that you will find. They all end in OH. Potassium hydroxide, sodium hydroxide, calcium hydroxide. Weaker bases, ammonium hydroxide, aluminum hydroxide, but they all have that OH negative because they are proton acceptors. This sodium hydroxide is in this. It's also used in making a lot of the new types of more fancy soaps. The measure of how strong or how weak the acids or bases is called the pH scale. And this is measuring water plus an extra hydrogen. The more extra hydrogens, the lower the scale goes. So your acids are down on this end here. The lower the number, the more acidic. Now, 7 is neutral, meaning it's got an equal parts of hydroxides and hydrogens. But as you go above 7, the higher the number, the more basic, or often called alkaline. So the scale runs from 0 to 14. If you have a acid that's in the 1 to 0 range, it is very strong acid and very, very dangerous. At the same time, if you hit a pH of 14, you have a very strong base that can be very, very strong and could be dangerous. They're both equally dangerous, although they're a little different in how they would actually affect you. Each level is actually 10 times stronger. So a 5 is actually 10 times more acidic than a 6. Each one goes up by a factor of 10. The same thing goes this way. Each one goes up by a factor of 10, 10 times greater. So by the time you're talking thousands and thousands of times greater by the time you get to the end. Which solution is a stronger acid, a pH of 4 or a pH of 2? With acids, the stronger the acid, the lower the number. So in this case, the pH of 2. A pH above 7 represents a basic solution. So you have more of those hydroxides and very few protons. All of these strongest bases are up here. Notice acids red, bases blue. Acids red, bases blue. There is a wide variety of acid-base indicators. You can make one out of that purple cabbage if you want. There's a real simple one on the internet for that. What happens when acids and bases react? Well, when an acid and a base are combined, the positive protons and the negative hydroxides tend to react, and you get a salt and a water. Now, this is called neutralization. And this is what allows us to bring down the acidity of certain things so that it doesn't become too dangerous. And different types of salts for different types of things are made this way. Neutralization is known as a double replacement reaction, which we talked about in the last chapter. You get a salt because you have the positive ion and the negative ion reacting to form a salt, and then you have the hydrogen and the hydroxide forming water. So here is an example of a double replacement. So the hydrogen trades places with the sodium, and then the chlorine trades places with this, and you end up with this H2O plus table salt. All right, is it an acid, base, or neutral, or does it describe an acid, base, or neutral substance? 0 for neutral, 1 for acid, 2 for base. Drano. Well, Drano has lye in it, and it is a very strong base. Probably a pH of around 14. Be very careful if you're using this in your house. That is a battery. Well, if you don't remember, I told you this earlier, batteries are filled with acid, specifically sulfuric acid, and they're going to have a pH of 1 or even 0. A lemon, well, lemons are sour. Acids taste sour, so this is an acid. All right, here we have a blue strip of litmus. We have dipped it into a solution and it turns red. So if you see blue litmus and it turns red, it has to be an acid. All right, that's pure spring water. Pure spring water is neutral. Soap. Soap has a base in it. Okay, here's it in a strip of paper and it changes nothing. That's neutral. If I add phenolphthalein, this is a base. If I put red litmus paper in and it turns blue, if it turns blue, it is a base.